They say the universe doesn't care about us, and maybe that's true, because for most of its 13.8 billion years, it existed without names, without language, without anyone to notice. And then we arrived. Not with a bang, but with a whisper. A new species on a small blue world, just learning how to walk upright, barely beginning to ask questions. Where are we? What is this place? And what can we become? In the grand story of the cosmos, we've barely turned up on the first page, but already we're dreaming about writing the final chapters. We are a curious species. From striking flint to splitting atoms, we've leaped through centuries of progress in the blink of a cosmic eye. In just a few thousand years, we've built civilizations, discovered physics, sent machines to other planets, and peered into the birth of the universe itself. But here's the question: how far can we really go? Not just as a society or a species, but as a force in the universe. Back in 1964, Soviet astronomer Nikolai Kardashev proposed a radical idea. What if civilizations could be ranked not by culture, not by technology, but by the amount of energy they can control? This became known as the Kardashev Scale, a cosmic measuring stick for intelligence. It breaks down like this. Type I is a civilization that can harness all the energy of its home planet. Winds, tides, solar radiation, geothermal heat, every what Earth can offer, captured and used. Right now, humanity is somewhere around type 0.7, still dependent on fossil fuels, still wasting vast amounts of potential. We're clever, no doubt. We've built smartphones and space stations, but in energy terms, we're toddlers with matches. If we ever reach type 1, we'd become planetary stewards, that we could control the weather, prevent natural disasters, and even terraform Earth itself. It would mark the first time in history we'd have true mastery over our environment. But that's just the first rung on the ladder. Type 2 is something else entirely. At this level, a civilization captures all the energy output of its star. Think about that. It's at every beam of sunlight, every nuclear reaction at the heart of the sun, channeled into power. Theoretical structures like Dyson spheres have been proposed, massive swarms of solar collectors orbiting a star like a glittering shell. Converting starlight into civilization-scale energy, with that kind of power, nothing stays local. You can build planets, dismantle them, move them, power cities the size of moons, and the limits of biology, of lifespan, of scarcity, they begin to break down. Then there's Type 3, a civilization that uses the entire energy output of a galaxy. Billions of stars become fuel stations. Black holes become tools. The very fabric of space-time is no longer a mystery. It's a playground. These beings wouldn't just explore the cosmos, they would sculpt it. To us, they'd be indistinguishable from gods. But they would have started out just like we did, wondering, stumbling, learning. So where does that leave us? Right now, we're fragile. We still argue over imaginary borders. We still poison the air we breathe. Still build machines we don't fully understand. But despite all that, we dream. And that makes us dangerous in the best way, because asking these questions, imagining these futures, that's the first step up the ladder. The Kardashev Scale isn't just about energy, it's about ambition. It's a reflection of who we are, and who we might become if we're wise enough to survive our own adolescence. We may be late arrivals on the cosmic stage, but the spotlight is finally on us. Now the question is, do we burn out before the second act? Or do we rise to write the ending? The universe is vast. Our time in it is short, but maybe, just maybe, it's enough.